Namaste students, welcome back to our 7th standard science class. How are you? I hope all of you are fine and safe. Dear students, schools are not reopened because of COVID-19 and I hope all of you are sitting safely in your house and watching online classes through laptop or mobile phone. So, before using laptop or mobile phone, you have to charge it. So, to charge laptop or mobile phone or to run electric fan or light up home, which energy is very important? Very good. It is electric energy or electricity. Today we are going to learn a new chapter, that is electricity. So, what is electricity? Electricity is a form of energy due to flow of electric charge. Do you know what is the symbol for electric charge? Symbol for electric charge is small letter q. It is represented by small letter q and its SI unit is coulomb. So, electric charge represented by small letter q and its unit is coulomb, and 1 unit of coulomb of charge is approximately equal to 6.242 into 10 power 18 protons or electrons. Understand? Then this flow of charge is associated with electric current. So, can you define electric current? So, electric current is defined as amount of flow of charge per unit time, and conventional symbol for electric current, that is capital I, and formula for electric current, that is I equal to Q by T. You know what is Q? Q symbol of charge and its unit is coulomb, and T time taken. What is the unit for time? That is second. Okay, very good. And unit for electric current, that is ampere, and it is also written as coulomb per second. So, unit of electric current is ampere or coulomb per second. Okay, when current is said to be 1 ampere. So, when 1 coulomb of charge flows through a circuit for 1 second, it is said to be 1 ampere. Understand? The next, conventional current. What is the meaning for conventional current? You might have seen in electrical circuit, mostly arrow mark shows the direction of flow of electric current in a circuit. And if you observed an electric circuit, arrow mark is from positive terminal of the battery to negative terminal of the battery. So, before invention of electron, scientists explained that it is due to the flow of or movement of a positive charge, and this movement of positive charge is termed as conventional current. But later scientists explained that it is due to the flow of electron, and electrons move from negative terminal to positive terminal. Therefore, the direction of conventional current and electron flow are opposite to each other. Okay, next. How electric current is measured, do you know? Yes, it is measured by using ammeter. Have you seen ammeter? Here it is. It is used to measure electric current. So, which instrument is used to measure electric current? Ammeter is used to measure electric current in a circuit. Here the symbol of unit is marked as capital A. Then to measure feeble current in an electric circuit, there ammeters are there which are calibrated in milliampere and microampere. What is the value for milliampere? 1 milli, that is 10 power minus 3 ampere. And microampere, what is the value for 1 micro? Very good, 10 power minus 6 ampere. The next, does electric charge move by itself? No, it requires energy. So, energy required to push or move electric charge from one point to another point is termed as potential difference. So, can you define potential difference? Potential difference is defined as the amount of energy required to move an electric charge from one point to another point in a circuit. Okay. How will you measure potential difference? It is measured by using an instrument called voltmeter. It is a voltmeter. Voltmeter is used to measure potential difference. And SI unit of potential difference is volt and the symbol is a capital V. So, what is the potential difference? Potential difference is the amount of energy needed to push electric charge from one point to another in an electric circuit, and unit of potential difference is volt. The next, let us see some important terms in electricity. So, first a resistance. Resistance, its symbol is capital R, and the formula for resistance, that is V by I. Can you define resistance? Resistance is defined as the ratio of potential difference across it to the current flowing through it. Understand? So, resistance is defined as the ratio of potential difference across it to the current flowing through it. And what is the unit for resistance? Its unit is ohm, and it is symbolically represented like this. This is the symbol for ohm. Have you seen a resistance? It is used in electrical circuit. This is a resistance. What is the meaning for resistance? Resistance means something resists the flow of charge in a circuit. Understand? And next term, that is electrical conductivity. So, conductivity, from the heading itself you can know its meaning. So, it is the measure of material's ability to conduct electric current, and it is symbolically represented by sigma. It is a Greek letter sigma, and its SI unit is Siemens per meter, or it is written as S per M. So, based on conductivity, materials are classified into two types. That in previous classes you have studied, they are good conductors of electricity and poor conductor or insulators. So, what are good conductor of electricity? Can you give example for good conductor of electricity? Yes, very good. All metals, that is silver, copper, aluminum, iron, all are good conductors of electricity. Then for whatever may be, but their conductivity varies for different elements. For example, silver, its conductivity is greater when compared with copper. If conductivity increases, resistivity decreases. Understand? So, next, electrical resistivity or specific resistance. Electrical resistivity or specific resistance, its symbol is rho. It is a Greek letter and its unit is ohm meter. So, resistivity. So, what is electrical resistivity? So, it explains how strongly a material opposes the flow of electric current in a circuit. Okay. The next, what is this? You all are very familiar with this. Very good. It is a remote control. Can you charge this remote control? No. Then we use an electric cell to function this remote control. So, electric cell, what is the meaning for cell? A cell is something which provides electricity to devices which cannot be fed directly by electrical supply. Understand? If two or more cells are used, it is termed as batteries. So, what are batteries? Batteries are collections of one or more cells. Understand? There are different types of cells are there. Some, I am showing some type of cells. These are different types of cells that we are using in our day-to-day life activities. That is for functioning of a toy car, remote control, then watches, mobile phone, etc. Then based on their properties, they are classified into two types, primary cell and secondary cell. So, can you give example for primary cell? Very good, a dry cell. Dry cell, that is used in torchlight, is a familiar one, is it? Yes, a dry cell is the best example for primary cell, and some other cells are there. They are voltaic cell, Daniell cell and Leclanche cell. Okay, this primary cells, they cannot be recharged, but secondary cells are recharged. For example, we are using secondary cell in mobile phone, laptop, etc. In generators, they can be recharged. So, secondary cells are recharged, and chemical reaction takes place in secondary cells are reversible, but chemical reaction taking place in primary cells are irreversible. So, chemical reaction taking place in primary cells are irreversible and they cannot be reused and recharged, but secondary cells are reused and recharged. And example for primary cell, already I told, Leclanche cell, Daniell cell, voltaic cell and dry cell. Secondary cell, example, lead acid accumulator. Have you seen lead acid accumulator? Very good. That is, it is used in automobiles. Car battery is an best example for lead acid accumulator. Then another one type, that is a nickel iron accumulator. Now, let us see the construction of a dry cell. Dry cell, it consists of a zinc vessel, and a zinc vessel acts as negative electrode, and the zinc vessel contains mixture of ammonium chloride and zinc chloride. Here ammonium chloride acts as an electrolyte and zinc chloride is used to maintain moistness in a dry cell. So, dry cell, it is not dry in nature, it is in the form of a paste. So, to maintain moistness, zinc chloride is there, and ammonium chloride, it acts as an electrolyte. Then at the middle of the dry cell, there is a carbon rod with a brass cap. There is a carbon rod with a brass cap, and it acts like a positive electrode, and this positive electrode is surrounded by a muslin bag which is filled with a powder of charcoal and manganese dioxide, and this manganese dioxide which acts as depolarizer. What is the meaning for depolarizer? During oxidation reaction, the formation of hydrogen into bubbles are depressed by this depolarizer. So, it acts like a oxidizing agent. Then the chemical reaction taking place inside this dry cell is similar to Leclanche cell. Okay, next, dear students, can you remember what you will do to turn the current on or off in an electric circuit? Very good, that is a switch. So, switch is an electric device to turn the current on or off in an electric circuit, and there are different types of switches are there. That is plug key, slide switch, rocker switch, toggle switch and taping switch. But nowadays in household wiring purpose, we are using a rocker switch. Have you seen this type of switch? This is rocker switch. This rocker switch is used in household wiring. And another switch, that is a slide switch. Slide switch is somewhat similar to the switches used in circuit breaker. This is a slide switch. The next, plug key and taping key. These are used in electrical circuit. So, this is a plug key. So, where this type of key is used? It is used in electrical circuit. Yes. What is an electrical circuit? So, what is an electric circuit? An electric circuit is made of electric components. Can you give example for electric component? Yes, very good. That is battery, wire, bulb, switch, all these are electric components. So, electric circuits are made of electric component, but if I ask you to draw exact battery or switch, it is difficult. Therefore, scientists, they put some symbols for this electric components. So let us see the symbol for electric components. First, battery, it has two parallel lines. One is a longer line and another one is a shorter, and the longer line denotes a positive terminal of the battery and the shorter line negative terminal of the battery. Next, wire, it is denoted by straight line. Next, bulb, it is denoted by a circle with a cross mark. Next, switch, two bubbles. If the two bubbles are not internally connected, it is said to be open circuit. If the two bubbles are internally connected, it is said to be closed circuit. Okay, are you clear about these symbols? So by using these symbols, we can draw circuit diagram. So circuits drawn by using these symbols are called circuit diagram. So you know, this is a plug key. It also acts like a switch. When it is open, now the circuit is break. Therefore, current does not flow through the circuit. It is said to be open circuit. When it is connected like this, it is said to be open circuit. When it is closed, circuit is called closed circuit and current passes through this. And next, there are two types of electric circuit. One is a series circuit, another one is a parallel circuit. So in series circuit, current flows through only one branch, that is, current flows through only one path. But in parallel circuit, current flows through different branches. Here two bulbs are connected and current flows through these two branches, that is, through multiple paths it flows. But in series circuit, it flows through a single closed path. And also in series circuit, the brightness of the bulb are not same. The brightness for first bulb and second bulb are not same, they are different. But in case of a parallel circuit, power is equally shared and brightness of the bulb remains same. Okay. Where this type of circuit is made, a series circuit? Very good. For decoration purpose, we are using serial light, there series circuit is used. And where parallel connection is used? In household wiring. There what type of connections they are doing? Parallel connection. Let us see series circuit. See this circuit? Here battery is connected to two bulbs through a single path, that is a closed path. So and that is a series circuit. And next, parallel circuit, here current flows through different path. It flows through two branches. So the two bulbs which are placed at opposite, placed at different positions. Understand? So I hope you understand the difference between parallel circuit and series circuit. The next, electric fuse. So electric fuse is another device. What is the use of electric fuse? Electric fuse is a safety device which prevents the damage of costly appliances when heavy current flows through the circuit. What is this? This is an electric fuse. So this electric fuse is made of a ceramic core and it has 2 points and a fuse wire which is made of a material with a low melting point which is connected between the 2 points. If heavy current flows through this fuse wire melt. So when fuse wire melt, it becomes open circuit and current does not flow through the circuit. And in electrical appliances, glass fuse is used. So glass fuse, it is a glass fuse fitted with 2 points and a thin filament is there. So, this type of cell where it is used in electrical appliances, that is electric devices. But nowadays, this type of electric fuse is replaced by miniature circuit breaker. Have you seen this? So, instead of this electric fuse, nowadays in household wiring, they are using this type of a circuit breaker. So, when heavy current flows through the circuit, automatically it get switch off. To resume electric power, we have to switch it on. Understand? So, this type of circuit breaker is mostly used. Next, about effects of electric current. There are so many types of electric effects, but 3 effects of electric current are very important. They are heating effect of electric current, magnetic effect of electric current, and another one chemical effect of electric current. So, first let us see heating effect of electric current. So, when current is passed through wire or heating element, that electrical energy is converted into heat energy. So, in which devices, can you give example in which devices electrical energy is converted into heat energy? Very good, in electric iron, that is iron box, it converts electrical energy into heat energy. Then water heater, room heaters, electrical energy is converted into which energy? Heat energy. And also the heating element which is made of material with a high melting point. High melting point means it withstands very high temperature. And in water kettle, that heating element is made of nichrome. So, nichrome, that is an alloy made of nickel, chromium and iron. And next, magnetic effect of electric current, that is explained by Hans Christian Ørsted, and he explained that when electric current is passed through current carrying conductor, it produces magnetic effect around it. One such application is electromagnet. And electromagnet, this principle is used in many electrical appliances that we are using in our day to day life. For example, electric bell is based on this principle. Then telephone, that also based on this principle. The next, chemical effect of current. Chemical effect, that is when electric current is passed through different conducting liquid, their dissociation of ions takes place. Okay, till now you have learned many important terms and some definitions about a dry cell electric circuit you have learned is in this chapter. Let us recall once again. So, what is electric current? So, electric current is the amount of electric charge moving per unit time, and what is the unit for electric current? That is ampere or coulomb per second. And what is the formula for electric current? That is I equal to Q by T. And how electric current is measured? By using the instrument ammeter. So, which instrument is used to measure current? That is ammeter. Then potential difference. How will you measure potential difference? By using an instrument called voltmeter. Then resistance. So, resistance, what is the formula for resistance? That is R equal to V by I. What is the symbol for resistance? That is ohm. Then electrical conductivity, that is a sigma, and its unit is Siemens per meter. And electrical resistivity, that is rho, its unit is ohm meter. Okay, can you give example for a good conductor of electricity? It is silver, copper, aluminum, iron are good conductor of electricity. Can you give example for insulators? Very good, wood, plastic, glass or insulators. The next, what is a cell, or what is the difference between cell and the battery? Battery is a collection of one or more cell. But what is a cell? Cell is something which provides electric energy to some devices which cannot be charged directly by electricity. The next, what is electric switch? Electric switch is used to turn current on or off, and there are different types of switches are there. Plug key, which is used in electric circuit. So, when the circuit is said to be open, in open circuit current does not flow. In closed circuit current flows through that circuit, and there are two types of connections are there, series and parallel. The next, electric fuse. Nowadays instead of electric fuse, mostly we are using a circuit breaker. Then effects of electric current, their heating element is made of nichrome. Nichrome is an alloy of nickel, chromium and iron. Now today I am giving an interesting activity. So make an electric circuit by using zinc and copper as an electrode, and apple, lemon, orange as an electric cell. You make an electric circuit of your own and find out which fruit gives the greatest brightness and the reason for that. Okay. Then next assignment, why do electric linemen wear rubber gloves while doing electrical work? And another one question, that is, what is the reason for electric spark in electric pole? Okay. I hope all of you understand thoroughly. If any doubt in this chapter, we will clarify it in next class. Okay. Thank you.